Now we're going to talk about an inverse of a function. So when given a function here, let's say given this function here, there are lots of ways of imagining what a function is. One way is to imagine it as a machine. So here you've got a machine here where it will execute this procedure here. So you can put it, you can give it a number. You put a number into the machine. Let's say the number 1. So you put the number 1 into this x here. Okay, so that would be 2 times 1 is 1 plus plus 1, so the overall thing here is 3. 3 divided by this 3 here, it will spit out the number 1. So here you can imagine this function as like a machine. So you put a number into here, it spits out this number here, which happens to be the same as this one here. But if you put in the number, let's say 4, okay, put in the number 4 into this machine here, put number 4 into here, so basically you putting the 4 into this x here, so this will be 8 plus 1 is 9 divided by 3, it will then spit out the number 3. Okay, and then suppose you put in the number, let's say I don't know, let's say 6 then. 6. If you put the number 6 into here, then this will be 12 here, 13 divided by 3, whatever that is. So so this one here will be 13 over 3. Okay, so if you put in the number 6, it will spit out this number here. If you put in the number 1, it will spit out the number 1. If you put in number 4, it will spit out the number 3. Now, an inverse of a function is you putting, well, it's you trying to invent a machine, a similar machine where if you put in this number, it will spit out the number 4. It's basically an inverse of a function. Is you working backwards, working in reverse. So it's you putting a number into a machine, and then it will work. Well, it's you putting this number back in, and then somehow it will spit out the number 6. So what that means is you've got to invent a whatever goes here, so that when you put the number 3 into here, so it's basically you putting the machine, it's you working backwards to get the number 4 here. So if you put in the number 3, it should spit out the number 4. If you put in the number 1, if you put the number 1 in here, if you put number 1 in here, so it's you working backwards, so it should spit out this number here, number 1, which also happens to be number 1. Okay, so when given a function here, you have to somehow come up with some sort of procedure which will allow you to work backwards, basically. Well, it's easier just for me to show it to you. So let's say you've been given this function here. This is how I would do it. Let's just say f of x is y. Let's just say that. So it's like this. Take plus 1. So it's like you working backwards now. Suppose you feed well, basically make x the subject. So here times both sides by 3. So it would be like this. And then take away 1 from both sides. So it would be 3y, take away 1 equals 2x. And then divide both sides by 2. So it's like this here, over what? Over 2 here. So x is 2. So x is this thing here. So the inverse of the procedure for this bit here, if you like, is actually 3. Well, I have to call it x, okay? Because later on I'm putting later on I'm going to put, well, I have to represent x. Basically, I'm going to have to put this into the x. So, well, I'm going to need the x here. So minus 1 over 2. Okay, now if you look at this now, so we are trying to work backwards. We are going to put the number 3 here into, well, working backwards. So we should get this number here, 4. Okay, so now I'm going to put, so imagine this number here is this one here. I'm going to put this into this machine here. So 3 times 3 here is 9. Take away 1 is 8. So this whole thing here is 8 divided by 2. That gives me a 4. You see, I've got a procedure here where if you put, well, but basically it's gonna, when given this function here, okay, when given this function here, the inverse of this function would be this, and this is a notation. Remember, notation means it's just a way we represent it. The inverse of this function here is written as this here equals this thing here. Equals this thing here. So it would be 3x minus 1 over 2. And remember, I need to put an x here, because if I leave it as a y, well, when you're looking at this, it's saying take x and then put it where you see x in here. You see, had you written the y here, where would you put this? Where? Well, you have to put the x in here. So so a function is, well, when you see this here, you have to search for an x, and whatever number is here, you put it into the x. You can't leave it as a y, really. So, well, anyway, when given this function here, the inverse is this bit here. Okay.